everybody. Thanks so much for joining us for today's episode of the TypeAlias Show live stream. Today we're going to catch up on some of the latest news happening in the Kotlin and Android worlds, as we usually do. We're going to take a look at truly immutable collections, not just read-only, but immutable collections, and some of the other neat ideas that are behind the Kotlin X Collections immutable library. I'm going to answer some of your questions and a whole lot more. So, as always, behind the scenes with me today is my lovely producer, who also happens to be my wife, Elizabeth. Round of applause for the producer. And let's see here. Before we get to everything, I'd love to check in with you all in the chat and see how you're doing. So keep in mind that, throughout the live stream, you're welcome to ask questions in chat, and I might or might not be able to get to all of your comments and questions. So if you know the answer to someone else's question, feel free to reply to them. And who knows, you might just make some new friends that way. So let's see who we've got out here. Love the opening. Yes, thank you so much. I animated that one over the course of I think 10 days. I'm pretty slow at it, but I was pretty happy with the way it turned out and keeping all the characters from some of the books and all that stuff. So yeah, need a guy playing saxophone. Yeah, so some of you guys might or might not know I used to play saxophone in a ska band a long time ago. So yes, it could use somebody playing saxophone in there. And we got some other people here. Good morning, or afternoon, or evening, wherever you are. Thanks for being here. All right, so for today's poll, I'm going to be talking a little bit later in the episode about some things with Compose. We've got some news with regard to Compose. I've got a question to answer from the bag of questions later on in the show. And so I'm kind of curious how many of you are using Compose either on Android or on multi-platform. So Elizabeth will get the poll out there and we'll check on that in a little bit. All right. So as some of you know, Elizabeth and I have a little miniature Schnauzer dog, and her name is Ninja. And I discovered something about people who have Schnauzers, and that is that people who have Schnauzers are really into Schnauzers. And we just got back from an event in Rome, Georgia, in the US, that's called Schnauzer Fest, where I'm pretty sure we had over 1,000 Schnauzers of different sizes, all parading down that main street of the downtown area there. And this is Ninja here. This is her first parade, so she just kind of walked up to everyone and on the side of the street and said hello and made sure everybody got a chance to pet her. So that was a lot of fun. She had a great time. We all had a great time. And also, if you happen to be into the show Stranger Things on Netflix, well, you might know that creepy house from season 4. That house is actually in Rome, Georgia, where we were. So we got a chance to drive past it and see it. And when we went by, they were still breaking down a few things from the set for filming from season 5, just like a day or two before we got there. So that was fun to see as well. But that was probably one of our last big trips for the year. We've got, of course, the real big trip coming up soon. It's about 6 months off still. But of course, it's KotlinConf 2025. Still a little ways up, but we're getting everything lined up for that one. Ninja is going to have to stay here at home for that one. But Elizabeth and I will both be there, and we're hoping to see you there as well. I'd love to get a chance to chat with you all. I'm not going to be doing any presentations there, but I will be there, and I'll probably find ways to just kind of set up on the side somewhere where we can shake some hands and meet a few of you guys. So speaking of KotlinConf, it does look like the early bird tickets might have sold out here. So we do have still the, looks like the regular admission tickets are still available. And so there's still obviously a really, good deal on all that. And especially if you can get your work to pay for it, that's even better. And as I mentioned last time, the call for speakers is still open, but you've only got about a month left to submit your session. If you've got some good idea for a talk that you'd like to do, just be sure that you get that in before the end of November there. I also wanted to mention, for those of you who have enjoyed the Design Patterns series of videos that I've been working on, we've got one from Isuru, who'd done one at the GDG Melbourne talk a few weeks back, and it's finally up here on YouTube as well. And he talks about how you can use Kotlin's language features to avoid the need entirely for certain patterns. And I had a chance to check out the presentation a little bit ahead of time, got a preview on that, and I thought he did a great job of pointing out some of the characteristics of these patterns and how you can achieve some of the same characteristics, or in some cases even better, just using some of Kotlin's language features. So we've got a link for that in the description of this video, so go show him a little bit of love on this video here. All right, next we've got Compose 1.7 just landed a few weeks ago, and it brings along some nice updates. I'm especially interested in the type-safe navigation is going to be nice. So if you have used the Compose navigation library for Android prior to 2.8, a lot of us developers were like, we just really didn't love the way that we had to pass arguments from one route to another, and there hasn't really been a good way to make sure that you're passing it in a type-safe way. And so in Compose Navigation 2.8 on Android, we got the type-safe navigation there, and it looks like now we're going to be able to use that on Compose Multiplatform as well. So that's great. Performance improvements on iOS. This looks pretty exciting as well. I've got a few friends who are iOS developers, and when I had conversations with them about Compose Multiplatform, they were just like, you know what? It's really cool, but it's just the performance isn't there. And you know, they don't want their users with a really jaggedy experience, which is understandable. Well, the JetBrains team here is reporting some pretty significant improvements to that. They've got a few different benchmarks that they've been running. And this first one here, they demonstrated that they hardly have any more missed frames here. And so as long as you can get your processing time to where you can update the screen in 8 milliseconds or less, since it's a 120 hertz iPhone screen, that's kind of what the goal is. So with this benchmark, they were able to get that pretty much below that line all the time, which is pretty encouraging. Now, they also mentioned down here about the garbage collector. This is still experimental, but you can opt into it. And we talked about this a little bit last time, since it's also on the roadmap, but it does now have the feature for concurrent marking of the things that are expired. So there's marking and sweeping. First, you mark the things that need to go, and then in a second phase, you toss them out, basically. So the marking is now able to be concurrent with the main user's experience. So you don't have to like freeze the UI as much. So that's really cool as well. So if you have an iOS Compose app, I guess try updating to 1.7 and Kotlin 2.0.20 and see how that performance feels. See if it's any better for you. We've got drag and drop on desktop. And I think I remember seeing something very recently about that also coming to other platforms as well. And I've got a hobby project where I wanted some drag and drop. And previously what I had to do was I had to implement it using Java AWT, the abstract window toolkit. So I kind of had to step out of the Compose world to do that. So I'm going to look forward to updating that project to use the built-in support for that now. And then finally down here, we've got the shared element transitions. And this is where you might have two screens and you kind of keep an image maybe or some other UI element between the transition. Actually, we can just hit the button here and you can kind of see, is that going to play? Oh, there it goes. Yeah, so you can like keep the image and just zoom into it for the next screen, that kind of thing. So it's been a pretty neat feature on Android to have that as like, I think it's kind of a neat user experience. So getting that one on multi-platform as well is going to be pretty neat. Now, this one just popped up this morning. There's a new article that they put out about the Kotlin multi-platform development roadmap and some of the updates that we can expect for 2025. I'm going to highlight this section here. For 2025, JetBrains is focused on enhancing the Kotlin multi-platform ecosystem, including upgrading Compose Multiplatform iOS to stable. That's cool. The first public release of Kotlin to Swift export. Oh yeah. And the all-in-one KMP IDE, as well as other significant improvements to the core technology, tooling, and libraries. So I think the release of getting iOS Target to a stable release in 2025, that's going to be a real big deal. And I think that'll make a big difference for a lot of people who are just kind of sitting on the side waiting for a little bit more stability for it. So that's pretty exciting. We've got the Jetpack Compose feature parity. So for those who aren't quite as familiar, when we say Jetpack Compose, we're talking about Compose on Android. So that's the one that Google primarily develops, and then Compose Multiplatform is the like multi-platform version of all that tends to be more on the JetBrains side. So iOS rendering performance, we just saw in the previous article about some of those improvements in their benchmarks, and they're now also talking about implementing benchmarking infrastructure just to be able to make sure that it stays at the good level that we are currently seeing. We've got down here a public release of a standalone KMP IDE. When I first read this, I thought, well, surely this is going to be Fleet, but they are saying here it's going to be based on JetBrains Fleet. So that could be interesting to see kind of what features are kind of tailored for the KMP experience on that IDE. So I'll be interested to see where that one goes. And then Kotlin to Swift export, we talked just a little bit about that at the very top. That's going to be another great one. I've had some iOS friends as well who, even just in using KMP, so not talking about Compose Multiplatform, but just Kotlin Multiplatform for mobile development, who just weren't into the idea of having to go through the Objective-C for the interop. So getting a direct Kotlin to Swift export will be really cool. And let's see, down here, I thought this was pretty cool under search for multi-platform libraries on the web. That'll be really cool. I didn't realize there are over 2,500 Kotlin multi-platform libraries available. That's a bigger number than I thought, and it's really encouraging to see how many people have been, like for a while, it was kind of hard to find anything for it. And all the recommendations were like, oh, use this JVM-based library if you need it. But seeing how many of the Kotlin multi-platform libraries are out there now, that's pretty encouraging. And then finally down here, we've got Amper. This is a build tool that JetBrains is kind of experimentally working on. And I'd love to maybe give that one a shot on the live stream sometime. Maybe we can see what we can do with that in another episode or two. So that we'll save that for the future. Okay, now it is not too early to start thinking about Advent of Code. I heard about Advent of Code a number of years ago, but I didn't quite understand what it was or how it worked. And my impression of it was that it was mainly some kind of a competition. And being someone who's not a very competitive person, I didn't really take much interest to it. But I did want to say that whether you are a competitive person or not, Advent of Code is actually a great way to sharpen your coding skills. So I wanted to just give you a little peek. I know we're about probably a month out here from the start of it, but I wanted to go ahead and toss it out there so you start thinking about it now. The way it works is that starting on December 1st and ending on Christmas, each day a puzzle unlocks, and the puzzle usually includes some kind of like little cute story that inevitably requires you to take some batch of data, a list of strings typically, and write some code to transform that data into some result. And then when you submit the correct result, you get a second puzzle. And that one typically riffs on the idea of the first puzzle, but adds some extra layer of complexity to it. Sometimes it's just a matter of like, if your solution on the first one doesn't scale to, to handle a larger number of, a larger input or whatever, that kind of thing. But it's usually in the same vein. So you update your code to solve that second puzzle. You submit the result, and when you get that one right, then you're done for the day. Now, typically, the puzzles ramp up in difficulty over time so that once you're about halfway through, it starts getting really easy to spend multiple hours on the solutions. So I usually just participate for the first week or so, and eventually I just end up having so many other things that I have to tend to. You know, you got family coming in for Christmas, you got travel that you're doing or whatever. So I typically just hang out for the first week or two, but it's still a great experience. And the Kotlin team at JetBrains usually will do some fun things for this event. Like, let me pull up the one from last year here. So this is from 2023. They have not said anything about it in 2024 yet, but just to mention some of the things that they've done in the past, they've had daily live streams where they can cover different solutions that people have come up with for the puzzles. A lot of times they'll have people from the Kotlin team on there. Occasionally they'll have folks from the community. I've been on there a time or two. And so that's a fun way to see just kind of a range of different solutions that people come up with and kind of help you think in a different way about the problem than you might have thought. They also have the channel on Kotlin Lang Slack, which is fun for sharing your solution. Some people get this. Some people get their solutions down to like 3 or 4 lines, and I'm always so amazed that they can just take a screenshot of their solution and paste it in Slack, where mine's like taking up multiple pages. But anyway, you got some really smart people there. They got leaderboards for those of you who are competitive. You can do that, and then they really, even if you're not competitive, if you just participate, I think a lot of times they end up raffling off some prizes and things like that. So, like I said, they haven't announced anything for it at this point yet for 2024, but something to keep an eye out for. I'd say probably in the second half of November is probably when we'll see something official from them on that one. So just keep that tucked in the back of your head there for something to be able to participate in the beginning of December. Okay, I think that's everything I've got for news for today. If anyone in chat has any other big announcements or releases in the Kotlin or Android spaces, let me know. But I think that probably will do it. So let's check in with a few more of the comments we got here. Franklin, always good to see you, Franklin. There we go. Nice. Okay, we got from Mr. Doug, we've got an Android development job in Germany 4 days ago. Super excited. Way to go, man. I'm so excited for you. That is fantastic. All right. And I think we're probably good with that. So let's check in, Elizabeth, if we got the poll results. We can check in on that. All right. So wow, we've got 45% of you using Jetpack Compose on Android and 15% using Compose Multiplatform. And yeah, almost 40% not using Compose. I don't know out of that how many of you are just simply not front-end developers. Like, we've got a lot of people who are Kotlin back-end developers and that kind of thing as well. But that is encouraging to know that we've got, around 60% of the folks on the live stream today are Compose developers in one form or another. So that's great. All right, so next we are going to look at Immutable Collections. Now, I'm assuming that most of you probably have some kind of working knowledge of collections in Kotlin, especially if we've got 60% of you who are working with Compose already. But if you're just getting started with the language, you can check out Chapter 8 of Kotlin, an illustrated guide, which covers the basics of lists and sets. I'm not going to cover the basics of them here. I'm just going to kind of do a quick flyby recap of how they work in Kotlin. So in Kotlin, we've got 2 main categories of collections. We've got a read-only collection. I'm just going to say lists because I'm going to focus on lists today. So we've got a read-only list, and creating a read-only list in Kotlin is very easy. Let me pull up my screen here. Okay, so yeah, we can just use the list of function like we're doing here and pass in the elements. This is the most basic way to create a read-only list. And a read-only list doesn't allow us to add or remove elements. So if we were to try to do just books to read.add, you see we get a compiler error here. So if we want to add an element to a read-only list, what we have to do is we have to assign it to a new variable. So we create a new list and we take the contents of the old list and add the new elements, or add a second list to it if we want. So again, the first kind of list in Kotlin is a read-only list. The second kind of list is called a mutable list. So we've got a read-only list and a mutable list. Mutable lists allow us to add or remove elements directly to and from the instance itself. So the type changes to a mutable list. And once we do that, we can just call add or remove or any of those other functions that are on that mutable list. So again, two general types. We've got read-only and mutable. Now, a mutable list can be convenient. It can certainly perform better than a regular read-only list, especially when you need to add or remove lots of elements. But there's a risk that comes with mutability, especially once we start working with concurrent code where one thread is looping over a list and some other thread is adding, removing, or changing its elements. And that's why most Kotlin developers prefer to use a read-only list whenever possible. Now, it's tempting to think of a read-only list as the opposite of a mutable list. But in terms of the type hierarchy, that's actually not the case at all. A mutable list is actually a subtype of a read-only list. So if we were to follow the common rudimentary guidance for object-oriented design, for example, we might even say that a mutable list is a read-only list because inheritance implies an is-a relationship. So the naming doesn't quite fit with what we would expect. And this is important because if we create a function that accepts a regular read-only list, we might make the assumption that its contents won't change, but that's not guaranteed. In fact, it's not even implied. So let's change up our code here. And to demonstrate what I'm talking about, we're gonna pass in this list of books to this print list function. And I'm going to add some code here to do a check on the list. And we'll say if the list is a mutable list, then we got the smart cast here, and we'll remove the element from it. Now, the thing is, it can be really surprising just how often a list is actually a mutable list. So let's run this code, for example. And we might expect that this line here will not run because you wouldn't expect this to be a mutable list. So we'll give this a chance here. This is when I make a pre-recorded video, I usually cut down the build times for you, but when we're doing a live stream, you just gotta sit here and wait for it. So we got an unsupported operation exception. And let me pull myself out of the way here a little bit so you can see better. So we get this unsupported operation exception, which is not really something that I think most developers would expect because this list of up here is, you wouldn't expect this to be a mutable list because we didn't say, a mutable list of there. And this brings along an even bigger problem. So according to this object's type, it says here that it's mutable. But at runtime, we discovered that we can't actually mutate it. And that means now we've got this disconnect between the declared type of this object, which is mutable list, and the actual semantics of the object, which is that we get a runtime exception if we try to mutate it. And this is exactly what happens when we disregard the Liskov substitution principle. This is like anytime you find yourself reaching for an unsupported operation exception where you've got a subtype that adheres to the interface of its supertype but doesn't actually provide any implementation for it like that. Anytime that you find yourself reaching for that exception, try to find any other way that you can to deal with the design challenge that you're facing, and really only use this kind of exception as a very last resort. Another problem that I mentioned earlier is the concurrent modification exception. And this one happens when part of our code is changing a list that another part of our code is iterating over and they're running concurrently. So let's update our code here. And in this one, I've got a few coroutines where one is going to print out the book titles here. And then we've got a second coroutine that's going to try to modify it by adding a new element to it. So let's give this a run. And we end up with a concurrent modification exception there. And so the reason for that is we've got this yield here. So after it prints the very first one, it yields, and this second coroutine runs and adds something to it. And then when it gets back to printing that second item, it notices that the list has changed. And so we get that concurrent modification exception. So if we need to guarantee that a list won't be modified, sometimes what we end up doing is we will create like a copy of the contents to make sure that no other code is going to be able to affect it. So for example, we can do this by creating a new array list and passing in the contents from the first list. And then instead of looping over the original list, we loop over the copy of it. And with this change, we can run it, and now it succeeds because nobody modified that copy. They modified the original only. And sometimes we call this defensive programming, where we're going out of our way in this function to ensure that all the other code is going to play nicely with this function. So even though from the standpoint of the interfaces, it would make sense for a mutable list to be a subtype of list, because mutable list does everything the list does, plus it adds functions for modifying the list. It also means that an instance of a regular old list isn't necessarily read-only. The list type itself makes no guarantees as to whether its contents can be changed. And so if what we want is a list that is truly immutable, what we need is a new subtype. We will need another subtype of list that sits alongside mutable list and represents a list that explicitly cannot be changed. And this is where the KotlinX.collections.immutable library comes in. Now this library is still in alpha, but it's been baking a long time. I mean a long time. I think its commit history dates back to like 2016, and I think its current incarnation has probably been around for a good 3 to 4 years at this point. This library gives us a new extension function. I just updated the code here. You can see I've got this ToImmutableList on the end here. And as you can guess, this is going to take any other kind of a list and convert it to an immutable list. And the type, as you can probably guess, is just called immutable list. Also has a type parameter. And now there's no way to cast this books to read to a mutable list. So when this code runs down here with this conditional, it's not going to succeed, and the code inside that block is just not going to run at all. So let's give this a run just to make sure I'm not completely crazy. There we go. Great. And you can even see we did a mutable list of over here, just to emphasize that you can convert a mutable list to an immutable list like that. So ToImmutableList list is also great for those cases where we otherwise would have defensively created a copy of the list like we did earlier. So let me update our code here again. And what I've done here is I've got the coroutines again, but instead of doing a new array list and passing in the old contents, we're just doing .ToImmutableList here. So we're still working on the copy, but we just did ToImmutableList instead. I'll give this a run and just demonstrate that this works as we expect. Yep, everything succeeds. And for what it's worth, this ToImmutableList function will only create a copy of the list if it's not already immutable. So if it is already immutable, then we'll get the exact same instance back here. So here I'm converting it to an immutable list before we pass it in. Then I'm also doing ToImmutableList list here, and then we're comparing the instances here. Note that I'm using the 3 equal signs. That's comparing the instances, not the values. So let's give that a run. And you see we get true back because copy and list are the exact same instance. Okay, now immutable list itself is just an interface that extends the list interface. It doesn't add any new functions or properties to the list type. And since it's an interface, it's not actually a concrete type. So let's dig a little bit deeper. Let me switch over to here. Okay. So below the immutable list on the type hierarchy is another interface named persistent list. So when we call .ToImmutableList, we actually end up with a persistent list. And unlike immutable list, persistent list actually adds a bunch of other functions that you can see I've got down here. And these all probably look pretty familiar to you. So you can see we've got add, remove, clear, and all of those are up here in mutable list as well. So what is the difference between them? Well, even though their function names and arguments look the same as their counterparts in the mutable list, you can see that each of these in the persistent list return a persistent list themselves. And so this actually sounds pretty familiar because it's a lot like the regular read-only list when you might add them to each other. It's kind of the same approach where you're going to need to assign it to a new list variable. So if we call add on a mutable list, the element's going to be added to that exact instance. But if we call add on a persistent list, that original instance is going to remain unchanged, and instead a new persistent list gets returned. So let me switch back to our IDE here and demonstrate this one. So we can cast an immutable list to a persistent list and add an element, like you see we're doing here. And we assign the result to a new object. Now, if we're planning to work with persistent list objects, we can just use the persistent list of function up here instead. So we just change this to, instead of list of, we'll do persistent list of here. And then we don't need to do the check anymore. We can get rid of some of these pop-ups. And like I said, in some ways it sounds kind of familiar. It sounds a lot like getting, when we get back a new list, sounds a lot like using the extension functions on a regular list like plus or the regular like plus operator or the plus function, either way. But even though they sound familiar, there's actually a very big difference in their implementation. So if we call plus on a regular list, we end up creating a new array list, and we put all of the elements from that last collection into that, and then we also add a new element. On the other hand, if we call add on a persistent list, the returned list can actually just refer to some of the same underlying data that the original list was using. And this wouldn't be possible if the original list could be mutated. But since we know for a fact that it won't change, it's completely safe to do this. So a pretty neat way that by sticking with immutable lists, we actually get some kind of neat implementation options that wouldn't be there otherwise. Now, for those cases where we need to perform multiple modifications, a persistent list also provides something called a builder type. And the neat thing about the builder is that it extends the mutable list type. So here you can see I'm using it. I'm just calling .builder here. And then we get to add and remove. You can see we're not assigning the results on these. We're just adding it directly to it. And then when we're done with all of those updates that we're making, we can just call build, and then that's the thing that gets assigned to the new variable. So we can also, because this is conforming to the mutable list interface, it gives us some flexibility to interact with other code that's expecting a mutable interface. So for example, let's create a new function down here that takes a mutable list. And inside this function, we will do our adding and removing. And then here we can just pass in the builder. So we're not passing in books to read, we're passing in the builder because that's the thing that conforms to that interface. And then when we get the result, we can still call build. So if your code is using a persistent list and you need to call a function that accepts a mutable list, maybe from a library or something, you can just pass the builder to that function and get the result back that way. Now, if you don't need compatibility with the mutable list interface so much, but you just want to make multiple changes to a persistent list, you can use a function called mutate. And here's what that looks like. So it works a lot like the other collection builders that you've seen, like build list, for example. We just call mutate on the persistent list and make our changes inside the block and then assign the result to a new variable. One difference with the regular collection builders is that so the regular collection builders will operate on the receiver parameter. So you could just do add and remove, or you could do this dot add and this dot remove, or you just say add and remove. But this one actually operates on the lambda parameter. So we got to use it or give it a name. So I'm not quite sure the reason for doing that. I tend to prefer the consistency with the others if we could operate on the receiver, but maybe there is a reason for that one that I am overlooking. So immutable collections are great for cases where you need to guarantee that a collection's data is never going to change. And we only looked at the list today, but immutable collections library also includes implementations for sets and for maps. So if you find yourself working on a project that could use not just read-only, but truly immutable collections, especially in a code base that defensively creates a lot of copies of collections, give this library a look and see if it might meet your needs. Okay, I am going to check in on, see if we got any questions. Let's see here. Yes, here we go. What is the right way if you want to run logic to add an element during an iteration? A queue, sometimes it's a requirement. So if you need to, if you need to modify a list, I try to avoid it at all costs, honestly. You can, like a lot of times I've seen developers do like a backwards iteration just using an index. So instead of using just for with the elements, or like using an iterator, I guess, really. Instead of using an iterator, you use just an indexed loop over it. And a lot of times if you're adding stuff, people will go backwards from the last to the front and add things in there while you're looping over it. Yeah, I really do try to avoid that if I can, though, just because it tends to get sloppy and error prone. And so we do have a lot of neat collection operations that we can use in the standard library. So if there are other ways you can do it, if you can, push things out to a new list at all, that would tend to be my favorite or my favored approach on that. But you're right. I guess sometimes you kind of get blocked in based on different things you're working with. How common is the scenario of defensively copying? I think it depends on how concurrent your application is. I think if you are just writing a simple end-to-end script, it's not going to be very common at all. If you know what to expect for this list, if you're not expecting it to be unchanging, for example, then you might not need it. But I think the defensive programming that way comes in handy more when you've got those the shared mutable state like that. That tends to be where it is. And of course, we're talking specifically here about creating a copy of lists, but the same idea applies to like any kind of data that you're sharing from one thread to another. Like the shared mutable state is the piece that you end up with a lot of gotchas on it. And so even if we're just talking about more like regular objects where some of their properties could change, even in those cases, a lot of times that you'll see defensive programming implement on those things as well. This is a fun response here. I would say pretty common depending on how paranoid you are and how many battle scars you might have. It is kind of true. Like the more times you've been bitten by that stuff, the more likely you are to jump in there and just not make any assumptions about the data that you receive. Any real-world scenarios where we would need to use persistent lists instead of a read-only list? So persistent list is really, it is the implementation of immutable list in that immutable library. And so if you're operating on immutables, like if you're saying I'm going to work with just immutable collections anyway, especially when you're working on multiple threads at one time, I do think that's probably going to be a bit more convenient than trying to like if your only other option is going to be to copy things to prevent the shared mutable state, then I do think that you're going to have a better experience with the persistent list. And you're probably actually also going to get better performance that way because it shares some of the data. And I didn't get into the implementation too much of it, but the idea is that it uses a structure called a trie, which I wasn't as familiar with, but it's like kind of like a tree, or when I looked into this implementation, it was a little more like a linked list maybe, where each node holds an array, in this case, an array of size 32. So you could have, like, instead of copying all of the elements, especially in a very large collection, it's going to be, at some point, it's going to very likely be more efficient to use a persistent list and copy that, because it doesn't have to actually do an array copy on the entire thing, but only on the different pieces that change. Okay, I think that probably is most of the questions for the Immutable Collections library that we looked at. So let's move on to the next section. I do see a few other comments, and we'll get to those. But first, what I want to do is I want to reach into our bag o questions for questions that were submitted ahead of time. Let's see. First one is from Paul, and this one I actually ended up kind of whittling down and paraphrasing just a little bit to make it fit on the screen here in two different screens. So Paul, I hope I caught the essence of it here. It says, my understanding of the original design patterns book is that by learning these patterns, communications among colleagues would be enhanced, but your Kotlin code is often so different from the original patterns that I wouldn't have made the association between your code and the original pattern. Am I missing anything? So the context here is that I've been creating a series of videos on YouTube where I take a pattern or two from the classic design patterns book, and that's this one here by the Gang of Four. And I take one of the patterns and I show how to implement it basically verbatim in Kotlin. And then I show how some of Kotlin's language and library features can kind of put more of a modern spin on it. So it's true that one of the benefits of learning design patterns is that we gain a sort of common vocabulary that we can use to discuss our code. And that's at an abstraction that's a little higher than just the coding constructs provided by the programming language. So for example, instead of having to say, hey, I took the behavior of this class and spread it out among multiple other classes, and this class can contain those objects and choose the one that best fits the current situation. Instead of saying all that, I can just say it's using a strategy pattern. And if you already understand the gist of the pattern, you're probably going to be like 85% the way to understanding the code. Now, the farther that we distance ourselves from the original structure of these patterns, the less valuable that shared vocabulary is going to be, right? So when I tell you that I'm using a strategy pattern, but I'm actually using lambdas instead of objects for the strategy objects, then, well, rather than being 85% the way to understanding the code, it's probably going to be, you're going to be more like 65% the way to understanding it probably. So yes, I would say that shared vocabulary is a very real benefit of learning design patterns. But it's actually not certainly not the only one, and it's actually not even emphasized that much in the original book. I was kind of surprised when I was looking back over the introduction the other day, and I really could only find it mentioned briefly as a benefit. The stated goal of the book is actually to create a catalog of design solutions that have worked well for particular types of problems in order for developers to just more quickly be able to arrive at an appropriate design by kind of reaching into one of these general options. And personally, I found that the most helpful part of learning design patterns is the process of understanding what they call the consequences of each pattern. But really, like, when I arrange my code this way, how does it affect the code reuse? Or how does it affect the complexity and the maintenance? Or how does it affect the flexibility to change this thing in the future? And I've also kind of been surprised as I've been working through the series. I've obviously been reading through the book again as I've been doing that. And I've been kind of surprised at how much flexibility there is in the prescription to the solutions. So like a lot of the patterns describe multiple variations. Some, like for the state pattern, for example, it's left to the reader to decide whether which object should be responsible for transitioning to a new state. And some it's going to be the context object, and others is going to be the state classes. And I found a quote even from the introduction that I thought was interesting. it said that the pattern provides an abstract description of a design problem and how a general arrangement of elements solves it. The solution doesn't describe a particular concrete design or implementation because a pattern is like a template that can be applied in many different situations. So in other words, it sounds like we get a lot of latitude in how we apply each pattern. But as Paul noted in some of the design pattern videos that I've done, my modernized solutions sometimes have been very drastically different from the original pattern, which certainly does cut down on that the benefit of the shared vocabulary. But I kind of hope that the heart of the pattern is still represented. In particular, I mean, I hope that the technical consequences are going to be similar to, and maybe even in some cases identical to, the consequences of the original pattern. So yes, the benefit of shared vocabulary definitely does diminish as we get farther away from the original, but the technical consequences where I really find a lot of the value for myself in those patterns, and I hope that those are still preserved in those solutions that you see in those videos. So thanks for asking that, Paul. I appreciate that. All right, we've got one more question from the bag. This one is from Paco. And Paco says, if you want to create a design system in Compose where we use a slot API that doesn't allow any composable, but only allows specific ones, how would you do that? And he goes on to mention in the original question an example of, for example, a toolbar where maybe you want the leftmost icon to only ever be a back button or a close button. And this is one that was asked back before the first live stream. So it was a while ago, and I kind of noodled on it for a while, and I tried out a few things and came up with some solutions, but then I think in the last live stream we didn't quite have enough time to get to it. So I'm going to try to step through that quickly here because we do still have a little bit of time. So let me share my screen again here. So I've noticed a few things about Compose code that I've worked with. And the first is that we typically tend to write top-level functions for our composables. And the second is that when those functions accept any kind of nested content, when they accept a composable, it accepts really any kind of composable. So for example, here, we've got just a simple app. Let me go ahead and fire this up to run it because it might take a minute to build it. We've got a button and a button is typically going to have like some text or an image, or maybe if you're really feeling fancy, you might do an image and text. But typically you would do something like this. Compose. That guy there. Okay. Yeah, so typically you do something like this. But the thing is, like, we really don't have to stick with that at all. So like, for example, here's another version of it that is, we've got a button, and I've just loaded this thing up, man. I've got like, I've got a column, I've got text, I've got a card using a cut corner shape, and then inside that I've got a text. And so this right here, this whole lavender piece is a button, which is really kind of odd, right? Because you're thinking like, that's the weirdest button ever. Like, why do we need that? So the flexibility that we get by using just kind of any composable at all can be helpful, right? Because then you're not really limited, but sometimes you do want to limit what can go in a particular location in your code. I kind of think sometimes by using just any composable, it's kind of like the user interface equivalent of just a function that accepts a type of any instead of a specific type, right? I kind of need to think about that analogy a little bit more, but with the production apps I've worked on, we've typically just embraced the openness of these composables. But Paco's question was definitely interesting to me, so let's take a look at whoops, that is not the right one. Let's do this here. So let's take a look at one possibility here. So here I've got some example code where I've got a toolbar composable. So the stuff up here, let's collapse these guys. We don't need all that. Yeah, so just come down here. So we've got a toolbar composable, and you can see we've got a button 1 and button 2, and we're just accepting this type here, which is basically just wide open, right? Any kind of a composable that you want to pass to it, you can pass to it, and that's what we're doing up here. So we're passing a button. And then down here, I just did a little document stuff so that we can have a toolbar and a some kind of document. So I'll show you what this looks like so you can get your bearings. Yep, so up here, this purple is the toolbar, and then we've got these two buttons, hello and goodbye, and I can tap those and we just get output in the console. So right now, our button 1 and button 2 are wide open. They just take any composable, completely unrestricted. And we do have the parameter names here that kind of communicate the intent that we expect it to be a button. But it really can be any composable at all. It doesn't have to be a button. So if we came up here, we could even just change this one to text, and everything's going to work just fine. We can compile that and run that and everything. So the question is, if we want to limit this toolbar composable function here so that it only accepts certain kinds of composables, what we can do is we can create a class that extends the composable function type. So let's come down here and we'll just do a new class. We'll call it toolbar button. We're going to pass in the text for the button. We're going to use that as the label and also for what we output in the console. And then here, I'm going to do @composable. And so this is extending the same type that we have up here. So this class is extending that type. And then, of course, we do that. We also have to implement its members, which is going to be invoke. So we'll implement that. I'm going to come on here and also put composable here. And then inside here is where I'm going to put the button. So let me see if I can just maybe grab from up here, paste that in here. And then instead of this, we'll just pass in whatever the text was. All right, and so now we can update our toolbar composable up here so that instead of accepting this type, we accept a toolbar button. And then, of course, that means up here we got to pass something in that's more specific. So we can come in here and just say toolbar button. Hello. And so now that all works, let's give this a run and make sure that we didn't break anything. All right, so it compiled and it runs. We can hit hello and goodbye, and that works exactly like we were hoping it would. So now we've got the type safety around the composable there. We know that we're accepting only certain types of composables. And if we want to further limit the options, as Paco asked about ensuring that the left button was only a back button or a close button, we can extend these types even further if we want. So just to kind of take it all the way on this one here, we can change this guy. I'm going to change this guy to open, and I'll explain that in just a minute. And then we can create another class for either back or close. I'm just going to call this finish button. And then we can create some subtypes from this as well. I'm just going to create an object for back button. Say back and, oops, call this close. Just like that. And then we just come up here and we say if the very first one has to be either a close or a back button, we'll just change this to a finish button. And then, of course, up here, just change this to one of those objects that we had. And we'll give this guy a run. So with this, you can see that works. We're not going to be able to pass the goodbye button, for example, this goodbye button into that first one. It's got to be one of the finish buttons. Now, obviously, I'm just printing out the text still here. If you're going to actually close or go back or whatever, you have to implement that. But hopefully you get the idea of what I'm aiming for here. Now, I'm not an expert on how Compose works on the inside. So if anybody in chat has like knows of any reason why this approach would be risky, I'd love to hear about it. I have not field tested this approach in any production apps. The only issue I've run into it, though, is that the type that we accept in our toolbar composable here, it has to have a concrete implementation of invoke. So let me show you what I mean by that. So here, I changed it up a little bit. I've just got this abstract class toolbar button, and I just did a hello and goodbye. And we've got the invoke is implemented in these subclasses, but not in this toolbar button. So with this one, as it is right here, we're accepting hello and goodbye down here. We can run this, and this is going to work fine. So we just give this a run. Yep, just fine there. But I can break this by just changing the parameter type here from hello button to toolbar button. So we'll say toolbar button. And you can see we don't get any compiler errors here. I'll run this again. And we get this exception at runtime. Let me pull this up so we can see it here. And the error is a no such method error. So it's looking on that toolbar button class for invoke with these, the composer and an integer parameter types. So I'm guessing that the compose compiler is trying to generate the overload for the version that it's going to accept the composer. And so we can actually fix this by, for example, if I just grab this and paste that in here. Now, keep in mind that this is not, like, this is abstract, and we're not actually using, we're not actually passing that type in. We're still passing in hello and goodbye buttons. But just by adding the invoke function here, it will actually work now. So it's a little bit of an oddity with this approach. And it was the only oddity I was able to find. But if you guys, like I said, if you guys know of any reason why that might be risky, I would like to know, because I do think type safety would be pretty helpful for the composables, but I want to make sure that it's not going to mess up anything else with the compose compiler with what it's expecting there. Anyway, so Paco, I hope that helps. Like I said, if anyone else in chat has ideas on this, I'd be interested to hear it. So we're coming up on an hour, but we got a few more minutes here. So let me see what else we've got here in the comments. Let's see, in terms of Kotlin books other than yours, do you have a top 3 you would recommend to someone trying to learn and get better at Kotlin? Sure, yeah, like I'm yeah, honored that you know about my book. That's very kind of you. Probably one of the best, most common ones is going to be the Kotlin in Action. They just came out with a version 2 of that. At the beginning of this year. It was not too long ago that they came out with the second edition of it, and that's written by a lot of the folks at JetBrains. I think Sebastian has contributed that. I think Svetlana, I imagine Elizarov probably has as well. So that one's definitely a good recommendation. Great way to learn a lot of stuff in Kotlin. The other one, kind of depending on what you're looking for, is also by Manning. It's called, I think, The Joy of Kotlin. If you're interested in how to do functional programming in Kotlin, I feel like that's been one of the better ones that I've come across for explaining some of those concepts in a way that works pretty well for Kotlin. So I guess I've only got 2 for you. Sorry about that. But yeah, if I think of any others, I can let you know. And you've got tons of other people, tons of other people writing. Those are kind of the big ones that I've kind of gotten the most out of myself. I haven't read all the ones that are out there either. So, we got a second part of it. in the context of trying to apply it to Android applications. Okay, sorry, I missed that part of it. Yeah, for Android applications, I'm kind of surprised that, the Android, like the Compose, I feel like is kind of a vacant space when it comes to books. I've looked around, there are a handful of books, but nothing that I felt like really had great reviews on it and stuff. So I feel like there's a little bit of a room for somebody to write a good book on that. I will say, when I was first learning Android development, the Big Nerd Ranch books were pretty helpful to me, and I think they updated every few years, and I think the version they've got now is, if it's been updated in the past year or so, stuff changes so fast on mobile development that it's kind of hard to keep up with it. But yeah, the Big Nerd Ranch guide to mobile development for Android and iOS are both pretty good as well. So I would recommend those. Yep, we got a class can extend from a function. Yes, yeah, that's not always a common thing, but yeah, it's that invoke function is the thing that you got to implement for it. Started a whole conversation, looks like there. Yeah, that's pretty funny. Let's see. So does the overridden invoke execute similar to compose code in a function? Yep. Yeah. So it is exactly what's happening. It's just I basically took the is basically what would have been a top level function and put it inside that that invoke function instead. So let's see. Any other questions we got here? Can you make an example of domain events with Kotlin? I don't know what you mean by domain events, so I might not be familiar with that concept. But yeah, if you can maybe send me a link to just like an example of what you're talking about, I might be able to whip up some implementation for it in Kotlin. Happy to take a look at that. How is Ktor versus Spring with Kotlin? Yeah, I think if you are kind of in the Spring world, you're in the Spring world, right? Like if you're using it for dependency injection, if you're using it for all of the like Spring security and all those different plugins, a lot of people who are using that are really in that world. They know it. It almost feels like you're not just a JVM developer, but you are, or a Java or a Kotlin developer, but you're like a Spring developer in particular. Like there's a lot of tooling there. So the people who are in that world are definitely very much in that world, and they're going to be very effective with it, and that's great. Go for it. I really do like Ktor, and I tend to use it as my starting point on a lot of different, little bit lighter things that don't have to be quite as, the things that don't have to be quite as enterprise, I guess I might say. As far as I can tell, it would hang perfectly well with enterprise apps and everything. I've never had any trouble with it. I feel like they've really been developing a lot of great stuff. Ktor 3 just hit stable just a few weeks back, so a lot of good stuff there, and they're including a lot of neat support for different things now, like server-side events, WebSockets, and all that kind of stuff. So a lot of good stuff in Ktor. So I kind of tend to start there if it's a small project, but if I'm working on a big team that's already got a lot of Spring services, for example, I'll just use Spring. All right. I don't want to miss anything. I know there are quite a few comments in chat today, so I hope I didn't miss anything here. What we got here? What's your take on use cases classes versus direct access into the domain layer classes? I can kind of go either way. I'm kind of fine. I mean, I guess the use case idea is nice in that it tends to restrict your class from getting overburdened. I think, if you're just using like, I guess what you'd call like a service class, you can kind of end up with a lot of bloat in there. And then when you try to separate it later, it can be hard. So I think for the sake of like single responsibility principle, I'm fine with the idea of use case classes. All right, and we just got Illustrated Motion here waving at me, so I'm going to wave at you because I think that is about everything that we've got for today. Now, the end of the year is coming up pretty quick. And a lot of you have asked about a print edition of Kotlin and Illustrated Guide, and I'm working hard to get the illustrations redrawn for print resolution. That way it'll look good when it's printed. I'm working to get all the code and annotations looking consistent from chapter to chapter and that kind of thing. So I'm kind of hoping that we'll have a print edition ready in January, but I really want to make sure that we get the quality just at the level that we want. So we'll take our time with it and make sure that we get things right. I don't know yet if we're going to have another live stream. Typically, we've been trying to get these every like 4 to 6 weeks. I don't know if we're going to get another one in by the end of the year yet, partly because of the live streams that the JetBrains team typically does around Advent of Code. I don't want to clash with those, and those are kind of every day for the first week or two of December. So stay posted via the email newsletter. If you're not already on that, you can sign up at newsletter.typealias.com. And that way you'll be among the first to know about any scheduling of new videos and new live streams. In the meantime, keep writing that Kotlin. I thank you so much for hanging out with me today, and I will see you next time.